Good morning, all. Hope I'm audible. Please message your attendance in the chat window. I hope the PPT is visible for you. So today we'll start with this topic, that is recursion. That it's a continuation of functions itself. So recursion means it's a function that calls itself. So suppose you have a function called as func. So what happens when there is a function call is that the control would be passed over to that function, right? So in the body of that function, you can see that there is a call again to the same function. So that is when it happens, the control will again go to the start of that function. So this is what is meant by a recursive function. So a function is calling itself. So if you can see, this function is calling the same function. So it is called as a recursive call. So if you have understood that, please message in the chat. Okay. So we'll see how it can be used in C. So you know how factorial is computed. So today we'll see how the same factorial program can be written by using a recursive function. So you know that factorial of 0, it is equal to 1. When you have factorial of 1, it is 1 into factorial of 0, right? So it will be 1 into 1. Then factorial of 2, you know that it is 2 into factorial of 1. So that is again equal to 2 into 1. When it is factorial of 3, it is equal to 3 into factorial of 2. That is again 3 into 2 into 1. So similar, if you take factorial of n, it is equal to n into factorial of n minus 1, right? So you can see that for factorial of 3, it is factorial of 3 into factorial of 2. That is n into factorial of n minus 1. Similar to that, factorial of 2 means 2 into factorial of 1. That means n into factorial of n minus 1. So that is how factorial is being computed. So the last step, you can see that n into factorial of n minus 1. So suppose you are writing a recursive function for that, you can write it in this manner. So this is the same thing. You can see that factorial of 4 means factor 4 into factorial of 3. That is 4 into 3 into factorial of 2. Again, factorial of 2 you need to compute. So 4 into 3 into 2 into factorial of 1. Then factorial of 1 you have to compute. So that is 4 into 3 into 2 into 1 into factorial of 0. So factorial of 0, it is 1. So it is 4 into 3 into 2 into 1 into 1. So the program logic is this, that is, you have to say, like, if n is equal to 0, then you have to return 0. I mean, factor of 0 is 1. So this is the terminating step. So here you can see that if n is equal to 0, you have to return 1. Else what you have to return is return n into factorial of n minus 1. Okay. So in the program, you can write it in this manner. So you have to write the C program. So you have to include the stdio.h. Then you need to write the function. So this is the function prototype. You are writing it as long n because you want the factorial to be computed for large numbers also. So you want to increase the range of the numbers that can be computed. So long n factorial of int n. So in the main, you can see that I have read a number, then I'm just calling that function in the printf itself. You can, again, you can use a separate variable for calling the function and all. But for simplicity, we have called it within the printf function itself. So now in the factorial function, you can see that the same set of statements. That is, if n is equal to 0, you have to return 1. Otherwise, you have to return n into factorial of n minus 1. So if I have entered 5, I'll be getting the factorial of 5 as 120. So how it is getting computed is this. Suppose I have factorial of 4, then factorial of 4 means what? You have to compute 4 into, that is n into factorial of n minus 1, right? So factorial of 3. So again, that function would be invoked. So it is 3 into, again, there n is 3. So n into factorial of 2 would be computed. Again, that would become 2 into factorial of 2 means 2 into factorial of 1. Then again, factorial 1 has to be computed. So 1 into factorial of 0. Then factorial of 0 means that is the terminating condition. So you have factorial of 0 means you will have a return 1. So again, that 1 is going back to the just immediate call for that factorial of 0. So it will go to here, right? So whatever is 1 into 1, that will go to the next call. So here it will go back to here. Then 2 into that, whatever is the value, that will go into the previous step. Then whatever is the result from 3 into factorial of 2, that will go into factorial of 4. So ultimately, you will be getting the value of factorial of 4. So that is how it is getting computed. So is there anyone who did not understand? If you have any kind of doubts, you can ask. So recursive functions means it should have a terminating condition. Otherwise, it would become like infinite loop. So why no response? You didn't understand? If I have to repeat it, you can say so. Okay. So I have got all your responses in the chat window. So now what you can do is do this program fast so that you will get you to know how factorial is being computed. So do this program fast, and after you complete it, message in the chat. So remember that when you write that recursive function, there should be a terminating condition. So this is the terminating condition for this recursive function. If you have completed it, do message in the chat. Okay, Tressa, share your screen. Okay, okay, fine. Alan, share your screen. Alan, okay, I'm not. Screen is not clearly visible. Okay, I hope you have done it. Amal, share your screen. Okay, I hope I don't see what it is the number that you have given. Anyway, I hope you have got it. So others also, I hope you people have done it. So we'll continue. So this is how the function call happens. That is, when there is a call to that function, the control will be transferred to that function. Again, if you give 4, what will happen? The else part would be computed. So it would be 4 into this factorial of n minus 1. That is factorial of 3. Again, the same function would be invoked. Okay. So that is how it is working. So is there anyone who did not understand recursion? If you have understood till here, please message in the chat. Okay, Abhirami, okay, Abhinav. Okay, Anne Maria Sarang, okay, Ashwin. Okay, so I guess every one of you have understood. Remember that recursion is an important topic and it might appear in the university exam also. So we have understood how to do it. That factorial program has to be done by using recursive functions. So next we'll see how sum of natural numbers can be computed. So you know that sum of 0, if you give, the result should be 0, right? Then sum of 1, if you give, it should be 1 plus sum of 0, that is again 1 plus 0, that is equal to 1. Sum of 2, again it is equal to 2 plus sum of 1, that is 2 plus 1 is equal to 3. So similar to that, if you go and compute sum of n, it should be what? N plus sum of n minus 1. So this is how you can have your recursive function for sum of natural numbers. So the program logic should be what? This sum of 0 should be 0. That would be your terminating condition. So if n is equal to 0, it should return 0. Otherwise, it should return n plus sum of n minus 1. Okay, so try to change that same code and make it sum of natural numbers using recursion. So update that program for this one. So change your program and make it sum of natural numbers using recursion. Okay, so have you completed it? Karthik, can you share your screen?
Yes, ma'am.
Okay. What is
Visible
that?
ആണോ?
Enter a number 4, sum of 4 is equal to 10. How can you say that? If you give a number 4, how should it give 10 as answer? Sum of numbers means what? If I give 12, it should give me 3. So change the
Oh,
program.
okay, ma'am. Okay, okay.
Abhirami, share your screen.
മാം എന്തോ എറർ ഉണ്ട് ഇപ്പൊ പറഞ്ഞ പോലെ സബ് വരുന്നു.
Okay, change it. Tirtha.
Yes, ma'am.
Okay, yours also it is same. Sum of what number you have given 5, sum is equal to 15. So before you say you have done it, check the output. Sum of numbers means what? If I give say 123, it should give me what? 6. This is the expected result. 1 plus uh, 2 plus 3. Sorry. Okay, okay. This should give me like, okay, okay. Sorry. I was thinking about sum of digits. It might be correct. So sum of 4 means 1 plus 2 plus 3 plus 4. This is the expected result. If it is correct, it is correct. So yeah, Karthik, it might be correct. I was
Okay, ma'am.
doing something else in between, so I forgot what I have given. So that was my mistake. In between, I was doing something else. That is why. So your answer is correct. So can we move on? So this you might have got. So next is Fibonacci series by using recursion. So you remember Fibonacci series, right? So we'll see how Fibonacci series is computed. So this is the Fibonacci series. If I give, that is, if I give say fib of 2, it should give me this 0, 1, 1. That should be my result, right? So the Fibonacci series, I hope you remember it. It is 0, then it should be 1, then it will add 0 and 1. It should give me 1. 1 and 1 will be added. It should give me 2. 1 and 2 it will be added and it should be giving me 3. So this is how Fibonacci series is computed. So that is what is written here, the first part, the Fibonacci series. So it is always computing the sum of the previous two digits and this is the next digit. So it will compute 1 and 2, it will give me 3, 2 and 3 it will compute and it will give me 5, 5 and 3 it will compute, it will give me 8, 5 and 8 it will compute, it will give me 30. So it will go on like that. Okay. So we'll take two special cases here, that is fib of 0 and fib of 1. So Fibonacci of 0, it should give me a 0. That would be my first result. Fibonacci of 1, it should give me 1. So that is my second result. Okay. So if I want to compute Fibonacci of 3, it should be what? Fibonacci of 2 plus Fibonacci of 1, right? So again, Fibonacci of 2, again it can be split into 2. That is Fibonacci of 1 plus Fibonacci of 0 plus Fibonacci of 1. So that is how the Fibonacci series is computed. So if I give a Fibonacci, say some value, say index, it should give me Fibonacci of index minus 1 plus Fibonacci index minus 2. So this is my recursive call. Okay. So if I have to write it as a recursive function, what I have to do is I have to create a Fibonacci recursive function. So before that, I have to read what the number of terms in that. Then I have to do like index is equal to 0. Then what I am doing is I am calling this function from a loop. So what I'm doing is I'm calling that function. So here you can see that Fibonacci int Fibo, that is my function, and I'm passing the index here. So here I have told like you have to have two separate things. That is, if n is equal to 0, I have to return 0. And if n is equal to 1, I have to return 1. This is taken as special cases. And otherwise, what I have to do is I have to return what? The sum of previous two terms. So this is how Fibonacci numbers is getting computed by using
Excuse me,
recursion.
ma'am.
Yeah, slide is not
Ma'am,
seen.
PT കാണുന്നില്ല.
So you should have told, no? Okay. I had stopped presenting when others were sharing their screens. So I'll explain it once again. So this is the Fibonacci series. I hope you remember the Fibonacci series. This is the Fibonacci series 0, 1, 1, this one. Okay. So how it is getting computed? The 0 is the first one. These two are our special cases. Okay. So after that, how Fibonacci series is getting computed is that if I add these two, 0 and 1, it will give me the next digit. If I add 1 and 1, it should give me the next digit. 1 and 2, it will give me the next digit. So similar to that, all the other rest of the digits are computed. So there is something called as index. That is, if I give Fibonacci of 2, what it should give? It should give me 0, 1, 2, 3, right? So that is how why index is given here. Now we have two special cases, that is Fibonacci of 0 is equal to 0 and Fibonacci of 1 is equal to 1. These two should be taken as special cases. The rest is computed like previous of 2. So here, if I have to compute Fibonacci of 3, what should be given? It should be Fibonacci of 2 plus Fibonacci of 1, right? That would be the fib of 3. Are you following me? So if I have to compute Fibonacci of 3, Fibonacci of 2 is what? Fibonacci of 2 is Fibonacci of index minus 1, right? Either if it is Fibonacci of 3, this should be fib of 2, index minus 1, plus index minus 2. That will give me Fibonacci of 1. So till here, have you followed? If you have understood till here, please message in the chat. Okay, Ashwin is okay. What about others? Okay. Abhinav, Abhirami and Ashwin, okay. So this is our program. So we have to create the Fibonacci series by using recursive function. So what you have to do is you have to include stdio.h because it is a C program. Then you have the Fibonacci function. So because I'm writing it after main, I have to let my compiler know that I'm going to use a function like that. So I need to have a function prototype. So after that, I'm writing the main. So here you can see that I need to enter the number of terms because how many terms I need to know so that I can display the Fibonacci series. So I'm reading that number of terms in NP. Now I'm displaying like Fibonacci series, then I'm having my index, which is equal to 0. Now you can see that there is a loop because I have to display the Fibonacci series up to whatever is the number of terms given. So in that, what I'm doing is I'm calling that Fibonacci function. So here, what I'm doing, I have to take two special cases. That is my first two things, 0 and 1. So here, if n is equal to 0, what I have to return is return 0. If n is equal to 1, I have to return 1. Those are these two cases, 0 and 1. After that, what I have to do is I have to do an addition between the previous two terms, right? So if it is Fibonacci of 0, 1, then 2 means I have to add these two, right? So that is why I have returned Fibonacci of n minus 1 plus Fibonacci of n minus 2. So if I give Fibonacci of 2, what I have to do? I have to return Fibonacci of n minus 1 plus n minus 2. That would be Fibonacci of 1 plus Fibonacci of 0. Okay, so that should give me 1. So the return value would be 1. Okay, so that is how it will be displayed. So I'll be getting 0, 1, 1 if I give Fibonacci of 2. So have you understood here till here? If you have understood, please message in the chat. Okay, Sandesh, Abhinav, Tirtha, Ashwin. Okay. So this is the next question for you. You need to write a C program using recursion to find the sum of digits of a number. So this is the program that I was thinking when I checked the program. So you can do this program as your homework. So you need to write a program using recursion. So this will be created in the Google Classroom. So you need to do a program using recursion to find the sum of digits of a number. So sum of digits of a number means if I have 123, I have to get 6. So you know how that program can be done in a by using a normal loop, but here you have to make it as a recursive call. So I'll be giving you homework. You have to do it before you come to the class on Tuesday. So you'll be having more than one question in the Google Classroom. I'll post it there for recursion. So if anyone did not understand the basics of recursion, you can message me and ask later. So till here you have understood, right? Is there anyone who did not understand recursion? Remember that the same thing you need it in Java and all. So recursion is not confined to C language. The same logic would be used in Java, be it Java or Python. So that is for today. You'll get your homework in the Google Classroom. So, okay, thank you.